So on this note, I wanted to introduce the panel today. Every person I've invited on stage, and Ramani Narayan, who is going to join us now on Skype, have been invited because they offer a very unique solution to the plastic pollution problem. And what was really funny to me is that even in the terminology, it is clear how policymakers and businesses differ. In business, we call it front-end solution. Policymakers like to call it source reduction. So for those of you who wonder, it's the same thing. We're talking about products and solutions that help reduce plastic pollution at the front. The first speaker, just because we wanted to mix it up a little bit, and only because I can't give his presentation, is Professor Ramani Narayan. And Dr. Narayan has 130 referees publications in leading journals to his credit, 25 issued patents, and several pending patents, edited 3 books and 1 expert dossier in the area of bio-based polymeric materials. He's a professor of chemical and biochemical engineering in Michigan State University. And I should say he's one of the world's leading authorities on bioplastics. He's joining us via Skype from the United States, and I'm hoping we can make this work. This is his presentation because there is no way I can speak to all the formulas that are there on page 5 and 6. So let's see, do we have Ramani on Skype? He will join us in a moment. While we're calling him, I should just tell you a couple of things about him and why I invited him to speak. Bioplastics is an emerging segment that will help us address the issue of plastic pollution. It's also fraught with problems. And problems, misconceptions, greenwashing, and oftentimes it does us more disservice than help because various people claim that they're a bioplastic provider and the promise falls short of really what it can deliver. So Ramani has done an extensive research on what really comprises biodegradability. And his research encompasses design and engineering of sustainable bio-based products, biodegradable plastics and polymers, biofiber reinforced composites, reactive extrusion polymerization and processing, studies in plastic end-of-life options like biodegradation and composting. So we'd like him to speak a little bit about what really is the opportunity in bioplastics, as well as what are the issues and the misconceptions. What does he find as somebody who has several commercial patents as to be his greatest challenge? So Ramani, we have you on stage right now. It's a static image, so it doesn't matter if you smile. But if you start with your presentation, I can advance the slides if you just tell me when to do that. Thank you. We just introduced you.
Okay, great. Thank you. If I can put my screen share, can I advance it, or would that be possible?
We can try.
All right. So here's my screen. I don't know if you can see that. Can you see the screen? Right
now what we see is your first slide, the promise of bioplastics.
Okay, great. So I can then do that. So here's so what I want to talk about in a very few minutes of this is, thank you for having me there. I want to talk about bioplastics and specifically want to talk about the bio-based carbon from plant biomass and designing for end of life. So that's the basis of what I'm going to talk about. All right. So let's begin. The first thing I want to talk, so that we are on the same page, to recognize that plastics are pervasive, universally used, and find application in almost all parts of our lives. Just look around you and you have a lot of plastics. It's all the way from agriculture to electronics to construction, transportation, so on and so forth. Now, obviously, there is overuse of plastics, there is misuse, there are all sorts of issues associated with it, but fundamentally it does help in preventing spoilage, safe products, lightweight, hygienic, healthcare, and so they offer value in every aspect of our life. All right, so these are the value attributes of plastics, but there are some major issues, and there are two issues I want to address, which is where the new move towards a more sustainable plastics comes from. And the first one is got to do with carbon footprint, right? And all of you are very familiar with this word, but I want to split it. I want to talk about the carbon footprint arising from the carbon in the product, all right? As opposed to saying that, can I use a biological plant-based feedstock or a petro-fossil feedstock, and what is the impact on that? There is also the carbon footprint associated with the process. That means you're going to take this feedstock, whether it is bio or petro, and convert it to a product, and that's where the LCA methodology and the impacts come into play. Let me point out that the value proposition for the bio-based plastics, and you've heard a lot about it, comes from the first carbon footprint. That is the origin of where the carbon is coming from. Okay, and we'll talk about that in a minute. The third and more important part is end of life, and it is this one which has caused a lot of problems for plastics and provides a very negative image of plastics. What happens to product after use when it enters the waste stream? So plastics manufacturers and users have to really work on ensuring that there is a end of life with recycling. There is an end of life like biodegradability, and when you say biodegradability, what do you mean biodegradable? You know, we are all biodegradable. Everything around you is biodegradable, so there's a time, there's an environment, and the environment and time is there. It's also useful in agriculture. So, but one has to be very, very careful, and this is the unfortunate part of something good, is that there is a lot of misleading and deceptive biodegradability, compostability claims. So beware. Remember that everything is biodegradable, so people seem to claim this with impunity without any scientific rationale. Okay, so with that as the background, let me address the first part of it, which is to ask the question, what value does bio-based plastics offer? And remember, when we said bio-based, it is the origin, the beginning of life for the plastic. And very simply, by switching from the petro-fossil carbon in the polymer to a biorenewable carbon, we will reduce the material carbon footprint, okay? And remember, this is separate from the process. In other words, it's going to reduce CO2 emissions, which is directly related to global warming, climate change problems. There are two other very important value attributes for the switch. One is energy and environmental security. So we're not focused on one volatile region in the Middle East or wherever this is available, but wherever biomass is grown, and it's almost over the entire world. And economic development, we can make it sustainable at the rural farm forestry industry. Okay, so if you look at material selection, the first take-home message from this slide is as follows. Bioplastics is comprised of what I call bio-based plastics. So when you hear the word bio-based plastics, remember they're not necessarily biodegradable. Biodegradability has got to do with end of life, all right? And biodegradable plastics are not necessarily bio-based, beginning of life, the origins of the carbon. So make sure that you understand this concept. And unfortunately or fortunately, bioplastics, the word bioplastics encompasses both bio-based, the beginning of life of the product, that is it coming from a petro feedstock or a bio feedstock, and biodegradable compostable plastics, which goes to the end of life. Okay? So with that additional information, let us understand this switch, okay, the switch from petro to bio. So you have two kinds of feedstocks. You have your oil, coal, natural gas, and you have the bio plant feedstocks. It be crops, it could be residues, tree plantation, algal biomass. Today, we can, taking the fossil carbon feedstock, we can convert it through a refinery process, polyethylene, polypropylene. Or these are your major plastics used. You can make other materials also. We can also, instead of using the fossil feedstocks, we can take a plant feedstock, convert it to monomers or small molecules, ferment it to ethanol, and then make the same polyethylene, polypropylenes, and PETs using the plant feedstock. We can also make new polymers, PLA, polylactic acid, PHAs, polyhydroxyalkanoates. These are the new generation of plastics, which are both bio-based. That means the carbon is coming from a plant feedstock, and as I will show later, it can be disposed of in a biodegradable composting environment. Now,